Hello everyone, my name is Komasinyolo. Welcome to another video by Attention Matrix, where we try to make learning fun and easy. Please comment, like, and subscribe if you would like us to continue making this content and you enjoy it or find it helpful. Now on to the next video. Let's get right into it. Okay, welcome to a video on logarithms. Okay, so it's another mathematics video on logarithms. That's what we will be focusing on in this video. We will be looking at what logarithms are, why we use logarithms, and we will be looking at the laws of logarithms. Okay, so let's get right to it. So firstly, what are logarithms? Why do we use logarithms? Well, remember when we covered the exponential function in one of our earlier videos, we had the following. We had the Cartesian plane like that when we covered the exponential function, and we established a couple of things regarding the exponential function. Firstly, we established that the exponential function looks like that, right? We established that the exponential function looks like that, and we established that the exponential function has what we call an asymptote. Now, an asymptote, just to recap, is an imaginary line that your function or that your graph never touches. Okay, it approaches the line, but it never touches the line. So you can see there that your exponential graph is approaching your asymptote, but it's actually not touching your asymptote. That's what your asymptote is. Okay, and we know that the equation, the standard form of the equation of this graph here is y is equal to a to the power of x. Okay, so that's what we've learned. That's what we established in a different video. Now in this video we're looking at logarithms. Now you might be asking yourself, what do exponential functions have to do with logarithms? How do the two things relate? Well, remember on a separate video we covered inverses. Okay, we covered inverse functions. Okay, that's what we covered on a separate video, and we covered the inverse function of an exponential as well. It was one of the inverse functions that we covered, and we established the following about the inverse of an exponential function. First thing that we established, the inverse of this equation here, of this function here, we established that the asymptote of that equation is the y-axis. Okay, we established that the asymptote of that equation is the y-axis. So we established that the graph that we are going to plot, the inverse of the exponential function, always approaches that asymptote, but it never actually touches that asymptote. Okay, and we also established that the graph looks like this. Okay, so we established that the graph approaches the y-axis. Just don't forget to label your x's again. We established that the graph for the inverse of this exponential looks like that. It does that. Okay, and it approaches the y-axis or your vertical asymptote, but never touches your vertical asymptote. Okay, and we established that the equation for this graph, we actually expressed it in the form of a logarithm, but I'm going to keep it exponential for now. We established that in order for you to find the inverse of any function, you just switch the variables, right? Your x becomes your y and your y becomes your x. So we established that the equation of this graph is x is equal to a to the power of y. Okay, and we established that a is greater than 1. Okay, so this is what we established on different videos. Okay, you can look up the videos about inverse functions, and you can look up the video about exponential functions if you would like to recap, if none of this stuff makes sense. Now, in this video, we will be focusing on logarithms. Sorry, we'll be focusing on logarithms. Now, what do logarithms have to do with exponential functions? Let's actually get to answering that question. Now, I'm gonna replot my graph here, but I'm only gonna plot the inverse. I'm not gonna plot, well, I'm gonna plot the exponential as well, just to illustrate the point. Okay, so we said the exponential graph looks like that. Okay, and I'm going to rewrite that equation. Y is equal to a to the power of x, and I'm going to replot my logarithm, the inverse of my my exponential, and I know that this is x is equal to a to the power of y. Okay, and we know that a is greater than 1 in both instances. Okay, so now you will agree with me on the following point. If you look at this equation here and you look at its corresponding graph, if you look at the blue equation and you look at the blue graph, right, you will agree with me that y is always positive. Okay, for this graph, you will agree that y is always positive. Why? Because it's always above that point, and from that point going upwards, your y is positive. Okay, conversely, you will agree with me that if you look at the red graph, right, the red graph goes that way. It always approaches that, it always approaches the y-axis or your asymptote, but it goes that way. It's always that way. It's never this side. It's never that side, right? So then you will agree with me then that whatever value of x that you get, these are your values of x. These are your values of x. You will agree with me that since the graph is always on that side, then x is always positive, right? X is always positive. Now, since x is always positive, then your graph is always on the positive side. Okay, that's going to be important to remember. Now, you will also agree with me that, okay, so whenever we were doing inverses, say we were doing inverse, for instance, of a straight line. Let's say we're doing an inverse of a straight line. Let's just pause on the exponential for now. Say you had y is equal to x plus 1, right? When we found the inverse of this, what we did was we switched the variables. So where there's an x, we put in a y. Where there's a y, we put in the x. We just switch them around. Then we will get x is equal to y plus 1, right? But then what we went on further to do is we made y the subject of the formula. That's what we did in our video on inverses, right? So we made y the subject of the formula. So what did we have? We have y, right? If the 1 goes to the other side so that y stays on its own that side, what we have is x minus 1. And this would be the equation of the inverse. Okay, now, why am I telling you that? Well, I'm telling you that because I want you to take note of the following. If you look at this equation up here, this equation has x as the subject of the formula and y as an exponent, as a variable in the formula. But we want to make y the subject of the formula. Okay, we want to express this exponential function, this logarithm, this inverse of this exponential function. So we want to express the inverse of the exponential function in such a way that y is the subject of the formula. Okay, so that's where your logs come in. Okay, so this equation that you see here, we want to make y the subject of the formula. So far what we've got is x is equal to a to the power of y, where a is greater than 1 and where x is always positive. Okay, remember I said x is always positive. Why is x always positive? Because this graph is always on the positive side. This graph is always on the positive side of your x-axis. Here's your x-axis there. This is the positive side of your x-axis. Therefore, your x is always positive. Okay, so those are the two conditions that we have for your logarithm. For your inverse exponential function. So now what we will do is, okay, so since we want to have y as the subject of our formula, what we will do is we will add what we call logs to both sides. Now, what the log helps us to achieve is that it allows us to express this equation in in such a manner that y is the subject. Okay, so what you do is we simply introduce logs to both sides. Remember the concept of what you do on the left, you do on the right. So here we will have log, and then we will have x is equal to, we just introduce logs to both sides. So log, then we keep that a to the power of y. See, I kept this there and I kept that there. I just introduced logs to both sides of the equation. Okay, so after introducing logs to both sides of the equation, it turns out that we can make y the subject of the formula, and the equation that we get eventually, and I will get to that eventually in this video. I'll show you how I got to this, but now I'm just going to give you the result. What I will get is y is equal to log base a, and then this is going to be x. Okay, and then this is the logarithmic function, or this is the inverse of your exponential function. Okay, we have this equation on a separate video on inverses. Again, look up the video on inverse functions if you're confused, if you don't know where this comes from. Now, this is your logarithmic function. Now, logarithms have certain rules. Since we have this equation, and this equation is in terms of log, we need to know how to work with logs, right? So there needs to be certain principles that dictate how logs operate or how logs work. And this is where the laws of logarithms come in. Because we have a function that is in terms of log, then we have to know how to work with logs in order to solve mathematical problems. This is where we've got laws of logarithms, okay, or logarithm laws. Laws of logarithms. Laws of logarithms. This is where we've got laws of logarithms. Okay, so now how do we know what these laws of logarithms are? Okay, so well, we've got a list. It turns out that we've got a list of laws of logarithms that are easy to remember, and then I'm going to demonstrate each one of these laws using different examples. Okay, so firstly, the first law that we have, I have them besides me here. I'm just gonna copy the first law. Well, the simplest one, first principle, okay, number one, is that you've got the logarithm of 1 is equal to 0. It doesn't matter what the base is. You could have any base there, but our base there is a. Remember, when we were dealing with our exponential function, our base, which is that number there, was a, and that number is that number there. It's that number there. It's still a, it's still a. So I'm going to stick to a. Our base is a, and that number there, that subscript there, we call it the base. Don't forget that. We call it the base of your logarithm, right? Okay, so that's your base. Okay, so the logarithm of 1 with any base is equal to 0. That's the first law that you have to remember. So to demonstrate that, it doesn't matter what number you have there. It doesn't matter what base you have there, as long as the base is greater than 1. Remember, the base is greater than 1. Now, why is this base greater than 1? Remember, this is the inverse of an exponential. And for an exponential function, that is always greater than 1. Okay, remember that. So that's greater than 1. A is greater than 1. So I can demonstrate that with a couple of examples. Let's say you've got, if you take your calculator and you punch in log 2, sorry, not log 2. If you punch in log 1, you'll get 0, right? If you take your calculator and you punch in log 2, log base 2 of 1, you'll get 0. It doesn't matter what the number there is. Okay, if you take your calculator and you punch in log 77 here, and then that number there is 1, your answer is going to be 0. It doesn't matter what your number there is. Okay, it doesn't matter what your number is. I will show you why this is the case. Okay, so this is your first law. Okay, it's not your first law. This is your first principle that you should remember. As long as you see a 1 there, just know that you will get, this will be equal to 0 and it will fall away. Okay, so that's your first principle. Now your second principle is the following. Okay, so if you have log, let me just write the 2 there. 2, second principle. Okay, so if you've got log, and then you've got a base there, then you've got that same base there, this will be equal to 1. Okay, so for instance, if you take your calculator and you punch in log base 2 of 2, that's going to give you 1. If you type in log, as long as the numbers are the same, then you'll get 1. Okay, as long as these two numbers are the same, you will get you'll get 1. And let me just demonstrate something to you regarding these first two principles. Okay, so I'm going to give you a little trick that I like using. Okay, so let's say you've got log. Let's say you've got log base a x is equal to y. Okay, remember where this comes from. This is the inverse of the exponential a is equal to, this is from x is equal to a to the power of y. Okay, it comes from that exponential. Remember, where x is the subject of a formula, it goes back up there to what I was demonstrating. It is, where is it? Let me find it. It is that. Okay, that's the inverse. Remember, I was talking about that earlier on. Well, I want to show you a little trick, and this has helped me a lot in the past while I was still in school. So what I want you to notice is that this equation does that. If you want to convert your base to your exponential, it does that. Now, follow these arrows and see what they're doing, right? This base is pointing to that y there, and that y is pointing to that x there. Okay, I want you to notice the following. I want you to always remember this little circle that I drew here, because what it tells you is that your base a, right, a, which is your base there, to the power of y, is equal to x. Look at that. A to the power of y is equal to x. Okay, so I find that it's very simple. If I draw this little flow chart, if you will, or this little circle, I find it's very easy to remember how to convert your logarithms back to your exponentials. And why is this helpful? Well, if you look at the first two principles that I showed you, look at this first principle here. What did I show you? I said log of any base, log of 1 to any base is equal to 0. Now, what would happen if I draw that flow chart or that flow diagram? I point to the 0 points to the 1. If I had to convert this to an exponential, what would I have? I would have a, right, because that's my base there, to the power of what? To the power of 0 is equal to 1. And I officially converted that to my exponential. What do you notice there? That is my base to the power of 0. What do you know about anything to the power of 0? Well, anything to the power of 0 is 1. And this is why this law or this principle holds. Because anything to the power of 0 is 1. And therefore, this is proven by that exponent there. Because a, doesn't matter what a is, doesn't matter what number you put in there, any number to the power of 0 is going to give you 1. Okay, and that's how you can remember this principle, or that's how you can, you can sort of work your way around to dealing with this principle. Same thing with the second principle. If I draw that diagram, look at that. A points to 1, 1 points to A. What does that tell you? Well, it says A to the power of 1 is equal to A. Doesn't matter what A is, A to the power of 1 is equal to A. Is this true or not? It's true. Anything to the power of 1 is equal to that anything, right? Anything to the power of 1 is equal to that anything. And this is why this principle holds. Okay, this is why this principle holds. Because anything to the power of 1 is equal to that anything. Doesn't matter what that number is. Okay, remember though, a is greater than 1. But it doesn't matter what that number is. It will hold. Okay, so that's why that principle holds. So I find it very useful to remember this little circle that I drew here. So the circle starts at the base. So your base to the power of your answer is equal to that number there. Okay, so that's the principle that I would like to impart upon you. Okay, now so let's get to the actual laws now, and then we will demonstrate these laws through different examples. So I'm gonna come to the actual laws of logarithms. Law number 1. Okay, so law number one, the previous two things that I showed you were not, I wouldn't call them laws, I'll call them principles. Okay, this is just mathematical principles, or these are mathematical axioms. Okay, so anything to the power of 0 is 1. Okay, it's an axiom. Okay, it's just something that we accept in order to make life easy for ourselves in mathematics. Okay, and that also this axiom also holds. Okay, now we actually get to the laws. Okay, what I'll call the laws of logarithms, which is the whole point of this video. So the first laws of your the first law of your logarithms is going to be the following. You're going to have log. Okay, you've got your base a there, and let me just write it properly. You've got your base there, which is a, and then x plus log a y is equal to log your base there, and then x and y. Okay, these are very simple to understand and to follow. What does this mean? Well, it means that if you have the logarithm the logarithm of x with base a plus the logarithm with base a of y, then what you have is you multiply these two numbers and you use the same log with that very same base that these two share. Okay, so let's demonstrate that through an example. It's very easy to understand. Let's say you've got log base 2 of 2 plus log 2 of base 4. Well, according to this law, right, if the bases are the same, then you can multiply these two numbers together and use the same log for the product. Okay, so you multiply the two numbers together, this is x and y, and then you use the same log, okay, for the product. So what does this mean for this example here? What this means is that your x is 2, your y is 4, your base for both logs is 2. Okay, so you use the same log. So this is going to be, you use the same log because the bases are the same. You keep the base is 2, that's that 2 there, because the bases are the same. So you keep the base and you multiply the numbers together. So this is going to be 2 times 4. Okay, that's going to be 2 times 4. It's that easy. And then you just say that's log 2, and then that's 8. Okay, and then that's your answer. That's your answer. And if you want to find the answer to that, you can punch it into your calculator and you will get an answer. So what's log of 8 with base 2? Let's see. Cancel. Let's say log of 8 with base 2, and that's going to give you 3. Okay, so that's 3. So your answer in this case is 3. Right, and then that's your answer. Let's do another quick example. Let's say you've got log 3 of 9 plus log base 3 of 9 plus log 3 of base 2. What you have here, then your answer to this is, remember, the bases are the same. So what do? You use the same log because the bases are the same. You use that base and then you multiply these two numbers together. Okay, so the two numbers are 9 times 2. Okay, so then your answer for this example will be log base 3 of what? Of 18. Okay, and then you can punch this in your calculator and get a nice answer. Okay, so you will get a very nice answer. Your answer will be, let's see, log base 3, 18. Say you've got base 3, you've got 18, you get 2.63. 2.63 is your answer. 2.63. That's your answer. Okay, so the law is very simple. The law is very simple. Now, the law would not work in the following instance. If you've got log base 2 of 3 plus log base 3 of 4. The law does not work for this. Why does the law not work for this? Well, it doesn't work because the bases are different. 2 and 3. The base for this one is 2, the base for this one is 3. So the law does not apply. You do not use this law. You do not use this law for this example. You do not. Why do you not use it? Because the bases are different. The bases have to be the same. Okay, so what if you had, let's say you had this example. You had log 5 plus log 3. Okay, well, something that I forgot to mention earlier on is whenever you don't see a base, okay, whenever you don't see a base being written, that base is equal, the base is equal to 10. Okay, whenever they don't write the base of a log, the base is equal to 10. So basically what I'm saying to you is the following. Log 5, if they write down log 5 like that, this is the same as writing log 5 with base 10. Okay, so whenever there is no number there, just know that the number there is 10. Okay, know that the number there is 10, but you don't have to write 10. So usually we don't write it down. We don't write down a 10. We don't write down a 10. Okay, so for this, remember we're still looking at law number 1. What would you do? You'll say, okay, so what is the base for this? Well, you can see that both of them don't have a number, meaning that both of them have a base of 10. Okay, so well, then we know that this is equal to, you can write down the 10 if you want to, but you don't have to write it down. Okay, so what you have is log, you write it once with that same base, but the base in this case is 10, so I'm not going to write it down, and then you just have 5 times 3. Then what you have there is log 15. Okay, you can write down the 10 if you want to. There's nothing wrong if you want to write it down, but there's nothing wrong if you don't want to write it down. Okay, so that's basically the first law. It's very easy to understand. It's very easy to follow. Okay, so that's that law there. It's this law there, and you should have it in your formula sheet. I'm not sure if they provide it in your formula sheet. Just check. If they don't, then you should memorize it, but if they do, then that's awesome. Okay, so that is the first law. Now, what is the second law? What is law number 2? Well, law number 2 is actually the opposite of that. You've got log of a number x, and then with the base a, minus log of a different number, or it could be the same number, it doesn't matter. This is equal to log of that same base, and then instead of multiplying these two things, now what you do is you divide them. So you've got x over y. Okay, that's the law. Let's do a couple of examples to demonstrate this law. It's easy, it's not complicated. Log with the base a of a number minus the log with base a of a number is equal to, you write the log down once, use that same base, and then you just divide the two numbers. Okay, so let us demonstrate that. Okay, so let's say you've got log of 7 and then 5. This is 5 there, minus log base 7 of 4. Well, according to that law up there, according to this law up here, if I'm subtracting, right, and I've got the same base for the two logs, and I've got these two different numbers there, then what I can do is I can just use the same log. So this is equal to, you can use the same log if the bases are the same. If the bases are the same, you can use that same base, and then you just divide the two numbers. What are the two numbers? 5 is my x, 4 is my y. So you just divide the two numbers. So you've got 5 divided by 4. Okay, and that is your answer. You can simplify it using your calculator if you want to. This simplifies to, let's check on our calculator. We've got log with base 7 of 5 divided by 4, and that gives you 0, 0,11. Okay, so that gives you 0, 0,11. 0, 0,11. It's that easy. Okay, it's not complicated at all. Let's do another example. Let's say you've got log of 6 minus log of 3,5. Okay, log of 6 minus. Same thing applies. Remember, if you don't see a base, what is the base? The base is 10. If you don't see a base, the base is 10, but you don't have to write it down. We know that according to the second law, this is going to be, since the bases are the same, right? The bases are the same, then you write the log just once, and then you divide these two numbers. So you're going to have log of 6 divided by 3,5. Okay, and then you can simplify that further. You can write it, you can punch it into your calculator. Okay, and then you can solve. Okay, let's show you another example. Let's say you've got log of 7 again, and then let's say 8 here minus log of base 6, that's 7. Now, law number 2 will not apply here. Why would law number 2 not apply here? Because the bases are different. The bases are different. One has a base of 7, the other has a base of 6. So the bases are different. So law number 2 does not apply. Law number 2 does not apply. Okay, remember, law number 2 only applies if the bases are the same. If the bases are the same, a just has to be greater than 1. We don't care what a is, it just has to be greater than 1. Okay, then this law can apply. Okay, same as the first law, your bases have to be the same. Your bases have to be the same. Okay, for you to use it, base has to be the same. Okay, there's your first law there. Okay, I hope that makes sense. That's easy. The only difference between the first law and the second law is that you've got a negative here and you divide here. Whereas in the first law, you had a positive here and you multiplied these two. Okay, so that's the difference. That's very easy to remember. It's not difficult at all. Okay, so let's go to law number 3. Start it on a separate page. Law number 3. Now, law number 3 says, okay, let's just write it down here. They say log of a y to the x is equal to x log base a to the y. Okay, so I know it seems difficult because I'm copying it down, but it's not difficult at all. So what this law basically says is that if you have a log, or if you have a logarithm and that logarithm has an exponent, you are allowed to take that exponent and make it the coefficient of your log, just as you see it here. That's all that it's saying. Okay, it's not complicated at all. If you have a logarithm and your logarithm has an exponent there, take the exponent, make it your coefficient, then you've got that. Okay, let's illustrate that using an example. Okay, so if you've got logarithm 2 squared, what is your exponent here? Your exponent here is 2. What can we do with our exponents? You can take it and you can make it your coefficient. That's what the law tells us. So then if I can do that, then what this is 2 log of 2. There's my exponent there, which is now my coefficient. Okay, so my coefficient there used to be my exponent. So I removed it from there and I put it there. That's all that law is telling us. Okay, so let's do another example and see. If we've got log of x to the power of 4, this is the same as, there's my exponent there. I can take it and make it a coefficient. What happens when I do that? What happens is that I've got 4 log of x. That's all that it is. There's my 4 there. It used to be an exponent. Now it's a coefficient. Okay, that's all that this law is telling you. Okay, So let's do another example. Let's say you've got log, it doesn't matter what the exponent is, right? You've got log 2 to the power of x plus y plus z. Doesn't matter. Don't let stuff like this scare you. What is your exponent here? Your exponent here is x plus y plus z. Okay, that's what your exponent is. So what do you do with your exponent? You take it and you make it your coefficient. So what I will end up with here is I'm going to end up with x plus y plus z. Okay, that's my exponent there. Then all of that multiplied by log of 2. Easy. Nothing complicated about that at all. Okay, so let's do one last example. Let's say you've got log of x plus y to the power of 2. Well, what you have here, you can simply say, there's my exponent. My exponent is 2. My 2 can become my coefficient. So I'm going to have 2 times log x plus y. Easy peasy. Nothing complicated with that. Okay, so that's all that this law is telling us. Okay, so that is law number 3. Now, what is law number 4? Law number 4 is telling us the following. Law number 4 says log with base a of b is equal to log b divided by log a. Okay, so that's what this law is telling us. Basically saying that if you have a certain base and you have a certain number there, you can just split the log into 2 logs and then just divide them by each other, express them as a ratio. So let's remember what that let me just show you where this comes from. So let's say you remember from our exponential, we had x as our subject of the formula and we had a to the power of y, right? Now, and I said to you, we convert this by putting logs to both sides, right? Well, I'm just gonna do this. We put log here and log there, and you put in your equal sign. Then you've got log of x, that's that x there. Then you've got your a to the power of y, right? Now, from law number 3 that we just looked at right now, look at law number 3. We just looked at it right now. Law number 3 says if you have an exponent, you can make it your coefficient. Okay, and we did a couple of examples demonstrating that. Here you have 2 as the exponent, now it's your coefficient. Okay, and we went through a couple of examples. X plus y plus z is your exponent, here it's your coefficient. Okay, so based on law number 3, look at what we have here. If you look at the right hand side here, we've got y as our exponent. So it means that we can take this y and make it our coefficient there. So if we do that, what we have is y log of a, then we've got log of x here. Okay, I've got log of x there. Now if we make y the subject of the formula, we just have to divide both sides by log a, right? If we want to make y the subject of the formula, we divide both sides by log a by log a. The log a's here cancel each other out, and what you end up with is y is equal to, there's that y there, it's on its own, is equal to log x divided by log a, log of a. Okay, and it turns out that this, according to our most previous law, is equal to log with base a of x. Okay, according to our most previous law. Okay, this is the fourth law. And look at what this is. Log a of x, we just made y the subject of the formula. Look at what this is. This is the same as, if you go back all the way to the beginning when I started this is the same as that equation of the inverse of your exponential. It's exactly that, okay, where we made y the subject of the formula. So that's your fourth law. So your fourth law is basically that. Okay, so let's do a couple of easy examples to demonstrate this law. So if you've got log 5. Okay, this is the same as log of 5 divided by log of 10. Why do I have a 10 there? Remember, if you don't have a number written down there, then your base is 10. Okay, so your base is 10, and according to this fourth law, according to law number 4, if you've got a base there, the base gets its own log and it becomes your denominator, and your b gets its own log and it becomes your numerator. That's exactly what we just did in this example. In this example here, your base is 10. It gets its own log and it becomes the denominator, and your 5 gets its own log and it becomes the numerator. Easy peasy, nothing complicated with that. Okay, so let's do another one. Let's do another example. Let's say you've got log of 3 with base 5. Well, you'll know from law number 4 that this is the same as log of 3 divided by log of 5 from the example, right? Your base is 5, it gets its own log and it becomes the denominator. Your 3 gets its own log and it becomes the numerator. Easy peasy, nothing complicated with that. Okay, so let's do another example. Let's say you've got log of z. Doesn't matter what you have, you treat these things the same, right? And then you've got 17 here. Well, then if you were to use law number 4, you have log of z, right, divided by log of 17. Why? Because your base is 17, so it gets its own log and it becomes the denominator, and your number there is z and it becomes the numerator. Okay, so that's how you use that law. Okay, and that's basically it. Those are your laws for your logarithms. Okay, so those let's just recap quickly. Law number 1. Law number 1 is the following. Law number 1 is the following there. If you have if you're adding logs of the same bases and those logs have numbers there, then you just multiply the two numbers, use one log and keep that same base. Okay, now the base has to be the same. Remember, the base has to be the same. For law number 2, if you are subtracting two logs from one another of the same bases, then you divide the two numbers by each other and keep that same base under the same log. Use them under the same log. That's law number 2. Law number 3 is this little equation here. If you have an exponent, you can take that exponent of your logarithm and turn it into a coefficient. Okay, turn it into, so there's your 2 there, becomes your coefficient there, 2. There's your x plus y plus z there, it becomes your coefficient x plus y plus z. There's your 2 there, exponent 2, it becomes your coefficient of 2. Okay, so that's your third law, and your fourth law is this equation here. Okay, so this equation here that I showed you where it comes from and what it means and why it's important. The essence of this equation is so that we can express our logarithm by making y the subject of the formula and getting it to that form so that we can plot the inverse of the exponential. Okay, so those are basically the laws of your logarithms. They're very easy to understand. You can use them in combination, and you can use them together in certain problems. In certain problems, they'll most likely present them to you together. You just have to know how to apply each one of them individually, okay, and then just synthesize your solution. So that's basically your laws of logarithms. They're not complicated. Practice will help you remember these laws. Okay, that's it. Till next time. Number one.